Well, as many of you know, we're on a multi-month trip through Canada, US, and Mexico, and this rig is mostly solar powered. And at the heart of this system is the SBMS 100 solar charge controller. And while I really like this controller, it does have one little flaw that's not really a flaw, but user error, and that is that you need to disable your breakers from the solar panel to the charge controller before powering it down. If you disconnect the power from the controller while the solar inputs are switched on, it will fry the main integrated circuit on the controller. So unfortunately, I've blown up our charge controller. Fortunately, we did bring a spare. Unfortunately, I've blown it up too. So today we're going to show you how to reflow a 64-pin, no-lead, quad flat part while living in your van down by the river. So in an earlier life, I worked in a facility that we had the proper reflow equipment to do this properly, but out here camped in the desert, you need to work with what you have. So basically, you're going to need something that's broken. Yours doesn't need to be specifically this broken thing, but it needs to be broken. You need some replacement parts, and you need some tools. So I'm not going to bombard you in the beginning with all the tools you're going to need, but I will call out what I'm using and where I got it when appropriate as we go along here. So as I've said before, we're going to repair this solar charge controller. This one's really slick because it has these flathead Allen machine screws that hold it together. So I'll take this apart real quick and show you. So the screws are all out of the back now. Let me just show you how clever this is. The whole controller is made up from stacked printed circuit boards. So as I take these layers apart, you can see these are a touch sensitive button, but they're just traces that go to a row of contacts here that then transpose down to the next layer. And these are just thick circuit boards. Oops, this one is the display in the front here. These are thick circuit boards that just stack together. And even these here are a printed circuit board, although there's no copper traces on those. And that's it, it all comes apart. And this back layer is actually really slick. It's an aluminum plate that he's designed with the traces etched right on the aluminum. It's not on the aluminum, but the traces are plated onto the aluminum plate for heat dissipation. So I think this is a really clever design. I just keep breaking it. Fully my fault, but I learned my lesson twice, so we're going to get to fixing it. So this is the main board that we're working on. This has the display on a ribbon cable, which is quite delicate. We need to be careful with that. And then this chip here is the main charge control IC, and that's the part we need to replace. So I've ordered the parts and some tools to be able to do this on the road. These are the charge controller chip. I'll put the links to everything in the description. If I forget to mention something, I will call it out. So I ordered 4 of them. I've also bought stock in the company. So let me show you how small these are. Using my ESD safe gloves and work surface. Can you get in here really tight on that? So this is the part. It's referred to as a 64 QFN, which means it has 64 pins along the perimeter of the chip. This is the bottom side we're looking at. And QFN stands for quad flat no leads. So there aren't even any leads to solder to. They're just little pads on the bottom of the chip. Okay, so you're going to, of course, need some special tools. And this is going to be tight and hard to show because it's a small thing and I have big hands. But I ordered this little 3-hand clamp. It's called a third hand, commonly used for soldering wires when you have no skill. You clamp one side of the wire and then you have the 2 conductors touching, and then you can solder it with a magnifying glass. But I'm going to use it to hold this PCB so that I don't burn my table and you'll see why in a second. And then I brought along a C-clamp, just a typical clamp. And I'm going to set this up on the edge of my table just because this little stand is too light and flimsy and would fall over. So you need access to the top and bottom of whatever board you're trying to reflow a part on. So that's a big part of the reason why I'm using this clamp. And it'll all make sense in a moment. But this was really inexpensive. If I remember right, it was about 10 bucks or less. So that's step one. Step two is you need to isolate these other fragile bits. So this foil ribbon cable for the LCD screen is fairly temperature resistant, but I just want it out of the way just for physical access to it. So I'm going to use a little piece of Kapton tape here. Thanks to M&M Overland for sharing that with me. Makes very good light color change filter lens also. And then this tape is neat stuff. It's polyolmide tape called Kapton, is the 3M trade name for this product. And it's heat resistant and will keep the hot air from getting at these other parts where we don't want it. And even though they may still heat up, it will prevent them from getting blown away or moved around by accident. So cheap insurance just to keep everything hunky-dory. There. So I've isolated all the stuff I don't want to affect, and I've got it square in the sight of the magnifying glass here. So the next thing you're going to need, obviously, are some tweezers. I got these from DigiKey, which is the electronic supplier I used in an earlier life. Same place I got the electronic components, I forget if I mentioned that. And you're going to need some solder. I have ordered from DigiKey as well, Chipquick SMD 291AX. It's a liquid solder where the solder alloy is in paste form, little tiny balls inside of a flux carrier. So it has this cap. Take that cap off, put this plastic needle dispenser on, get yourself a little piece of something, and it comes out there. I'll show you a close-up of that in a bit. So the thing about solder is as it gets old, it gets oxidized and doesn't reflow as nice. As well as this is likely a lead-free solder, and I prefer my solder super leaded. So you can all hate on me in the comments later, but it does flow at a lower temperature and it flows much nicer. So for that reason, I add new solder on top of all the old solder so that it reflows, and the new flux helps the old solder just flow nicely. So you'll see that here in a second. This is the next tool you're going to need. It's a very inexpensive hot air gun. This one's distributed by SparkFun Electronics. I recommend them highly. It's 20 bucks or so, and I got it on the same order from DigiKey. So it just runs off of 110, blows hot air out the business end, and you'll see up close here, if this is recording, and it is, the solder paste will heat up and then turn from this gray color to metallic. So you want to heat up the board gently and evenly. You don't want a hot spot necessarily. So I'm going to spend the first little bit just heating it gently and generally. You can see it goes from a shiny gray to sort of a darker dull gray, and then all of a sudden it's going to start bubbling and blistering. That's the flux melting and doing its thing. And then it'll go silver metallic colored. See that? It's starting to get shiny like the Terminator. And then when you see that flowing evenly all around, that's how you know the solder has melted and and get in there with your tweezers and just lift the old part out. So I don't know if you heard me, but once it goes silver metallic, that's how you know the solder has melted and the flux has helped the old solder melt. And you just get in there with your little tweezers and lift the old part out. So next you need to remove the solder that's residual here on the PCB, and for that I'm using just a regular pen soldering iron with a very blunt tip, you can see there, and this is solder braid or quick braid, and as you can see it's a woven copper wire like material, and it's just used to soak up the solder. And you don't want to linger on this too long, because the heat can cause that copper trace material to delaminate from the board, from the printed circuit board below. So just lightly and rather quickly, don't want to linger, like I said. Get it all off like that till it's nice and smooth. Maybe do one more. I don't want to say scour, but you want to almost scrub, just to release that, if there's any shmoo on there, get that off. So then the next thing you need to do is use your French-Canadian rubbing alcohol and Q-tip, and that will help lift the solder flux, the residual flux from the PCB, and clean off any fingerprint oils or any other inorganic or organic oils, and that looks pretty good. So I forgot to mention this before I took it off, but you want to verify that this marking, this square in the top right corner of the square, that little dot, that indicates pin 1, and on the printed circuit board here you can see that little circle, which is unique in that corner, and that indicates pin 1 on the circuit board. In this case, I already knew and that it went there, but before you take the old one off, you just want to make sure that you have the part in the right place. So be aware of that, because it needs to be keyed or clocked in the right direction to work, obviously. And so if you were doing this properly in a proper facility, you would have a stainless steel stencil with the holes cut out in the appropriate locations for the solder paste, and you'd use a squeegee to squeege it on there. In this case, you use a big old syringe and you dollop it on. I don't have an answer or a recommendation for how much to put on. And you'll see when I go to reflow this that it'll look like a big old mess anyway. So it doesn't really matter if you have a little too much. And you need a little bit in the center for the ground plane. So that big pad in the center is usually ground. So that's that. And then the magic bit, to take your chip and very carefully put it approximately in the center, approximately square. She's a thing of beauty. Mind the wind noise, we're firing up the hot air gun again here. And you want to keep this very flat so that, you know, when the solder reflows and melts, it doesn't go skidding, sliding down the side, and just give it the best chance to center itself. And you'll see that when the solder melts, the part will kind of shimmy and squirm right into place. So I'll try and talk through it. We'll see if you can hear me. Again, you want to heat the whole board generally. You don't want to thermally shock one area. So you'll see I'm moving the gun around, generally heating everything until I see the solder paste kind of go from this shiny gray. There you can see it sliding around on me. Goes from this shiny gray, smooth liquid to sort of a dull, crusty, coral, porous schmoo. And I don't know if you can see that, I'm able to affect its position just with the airflow. So I'll just slowly let that heat up until the flux sort of flashes off a little bit and it gets a little harder. There, it's kind of moving a little less. And this will take some time, about a minute, especially if you're using a small heat source as I am. This one is 300 watts only, so it's not ideal, but it'll work. So as the flux melts and evaporates, the paste becomes slightly thicker, and as you can see, I'm getting closer and closer here, and it's not really affecting it in the same way. It's not skating off on me. Just trying to heat it up, and you see on your right side there, the solder's melting. And I go to the left a little bit. There we go. See the solder all reflowing and melting. Don't pull out just because you think it's done. Give it a few seconds extra just to get the heat distributed evenly underneath on the ground plane and everywhere else. That should be good. And then there are reflow schedules, I guess you could call them, for the temperature path that it should follow. But I'm just going to slowly let it cool, or allow it to cool slower. That is, keep it slightly warmer for moments longer here. Generally warming it and letting it solidify slower. And there we have it. Looks like a disaster, right? You can see all these solder blobs here and here and here and here and here, and it's a big mess. But fear not. Everything is going to be okay. So as you can see, I've got these little shorts there. So we're going to use the regular old Weller pen tip, but instead of using this blunt, horrendous tip, I ordered, again from DigiKey, this replacement optional tip. Whoops. Now it has a bent tip, but you can see here, much finer tip. Okay, so this tip is up to temperature now. I'm just applying a little bit of solder to the tip, just to coat it with nice fresh solder so that it doesn't have oxidization and other gribblies on there. Wipe it off, and keep in mind that this will oxidize quickly because it's hot. Here's my... And then I'm going to just use this tip and take it off. Bad word usage there. Every time I touch the pads, a little bit of that solder is going to come and jump up onto this tip. So you can see there, I got rid of that one short. And then I'm just getting it off of the soldering tip by touching it to that same solder braid. So, don't know if you guys can see that there. And so as I touch it to the copper braid there, it just wicks into that. I've got about 6 of these shorts here. So now using some more rubbing alcohol, cleaning away any flux residue from the solder paste. Should be very little because it is a low flux, or rather a low residue solder paste. It actually says no clean required, but when you hit it with this soldering tip there, it does kind of scorch and leave it a little black. So next is to inspect your work, and I can't even see very well the quality of work I've done, so I actually use my phone and take some pictures. So I'll do that and overlay that here. This phone has an amazing camera. When I zoom right in, take a picture of each side. So there you can see between pin 4 and 5, the tiniest little whisker joining them. It's actually not pin 5, but the 5th pin on that side. So I do have the one really bad one, actually, maybe two I'll touch up again with the soldering tip, and then I'll show you the next step. Okay, so I've gone through with the fine point soldering tip and verified that none of the pins are touching, although they do look like soldered, hand soldered parts, because, or pins rather, because I soldered them with the soldering iron. So they don't have that smooth, glossy look like they should for a reflowed part. So I'm just going to reflow the solder again, and that will make them all nice and bulbous and beautiful looking. Okay, so I've just finished just reheating everything till the solder got all glossy and silver looking again, and then let it cool at its own rate. And I'm just going to splice in video from my phone, which is actually an amazing way to magnify this stuff. And as you can see in this clip, the solder joints are all bulbousy and silver, you know, not touching each other. And so the next step is to test it. So I'll show you how to do that next. So the next thing you're going to need is a multimeter with a continuity test. This basically will beep if there's any metal connecting between the two parts you're testing. Now obviously these pins are going to be far too large, rather the test probes are going to be far too large to touch each of those pins, but fortunately you can visibly see the trace here. So arrange this for this camera here. You can see that that first pin on the left goes here to this side of this resistor, and the second one goes to this side of this resistor, and it's not making any contact there. Then you go from that side of that resistor to the third, or actually the second and third are shared there, so we go to the fourth, no contact there, and so on and so on. I'm just going to work my way all around the chip, following these traces to these complementary parts, and verify that no two are touching. Now I already know that some are touching. For example, this here is ground, I believe, if I'm not mistaken. So you can't see that on the close-up camera, but back here I'm touching the USB jacket, and I know that this is ground. So I have the advantage of knowing which pins are ground because this solar controller is open source, and he's shared the schematic for it, as well as you can look up the data sheet for the part you're replacing, and some pins may be connected internally, or you know, the data sheet specifies this needs to be ground, and this also needs to be ground, and this needs to be ground, which is very common on a high pin count part like this. So you can just use that as a reference and just verify that if pins are shorting, that's probably why. So I'll go through these systematically off camera, one by one from pin to pin, making sure that there's no shorts, as well as the ground. We know that that big pin on the back is ground, so I'll hold the one probe on the USB jacket there, or the shield rather, and go through each of these pins. You can even just gently wipe the side of the part. And that pin I know should be ground, and the one next to it, but the other's not, and there's one more over here. So go through all these, make sure the adjacent pins that shouldn't be touching aren't, and ones that are connected to ground are, and then the next step, put it all back together, power it up, and hopefully everything works. Okay, so I've gone through every adjacent pin and through the ground plane. Nothing's shorting to ground, nothing's shorting to any of the pins, so it should be good. Now we just need to put it back together. Time to test it out. Okay, this is honestly the first time I've powered this up after changing the part out. So I need to have the battery management lead on there to start, and then I'm using a big battery bank. I'll show you. Got a ton of 18 650s in an ammo box as my spare power source for whatever. And some jumper clips will go from ground here to the ground lead here, sort of. And then from positive here to battery positive here without blocking your view. Communication error.
20 minutes later.
I've got this lead wired to the battery negative and this to battery positive. Clip that test lead on there. You can see it's it's able to read the RAM and the EEPROM, and the ISL 94203 is working. So success. So there you have it. I've actually fixed both of these already. I was lucky the first time, had no problems with any shorts. It went together just fine. The second one, I just shot the video for today, put it all together, and it didn't work. I had to take it apart, reflow some of the pins to get them to make proper contact. But 20 minutes later, I just filmed this, it boots up and works properly. So it's not impossible. Don't be afraid to try it. This equipment, which I'll link below, is super cheap. The hot air gun was about $20, and the solder paste is inexpensive. That is probably the hardest part that you could solder in a home gamer environment. You know, a 64 or 128 pin quad flat pack like that. So it's not impossible. Don't be afraid to do it. The worst case scenario is it will still be broken when you're done. Thanks so much for watching. We'll see you next time.